Okay, so graphing rational functions, we've gone through finding wholes and asymptotes and everything. So now let's get into graphing by hand. You have to graph by hand. So f of x equals p of x over q of x, where p of x and q of x are polynomials, q of x can't equal 0. Okay. So then the steps to doing this is first you simplify the function, and then you check for wholes. And then find the x-intercept by setting the numerator equal to 0. And then find the vertical asymptote by setting the denominator equal to 0. And then find the horizontal asymptotes using the rules that we used before. Okay, and sometimes people will say do the wholes last. I like doing them first. It gets them out of the way. And remember, the whole is a break in the graph. You find the x-coordinate first, substitute it back in to find the y-coordinate. So if we have f of x equals x minus 4 over x plus 4. There's no wholes here. It's already completely simplified. Nothing can cancel. So there's no wholes. Then let's find the x-intercept. So our x-intercept is where we set the top or the numerator equal to 0. So we have x minus 4 equals 0, which means x equals 4. So we have an x-intercept at 4, 0. And the x-intercept is always a point. So then we're just going to draw a point right there at 4, 0. Okay, which makes sense. Like, it's not going to cross at the whole x-axis. That would make it not a function. Okay. And then the vertical asymptote, that's where we set the denominator equal to 0. So we have x plus 4 equals 0, which means x equals negative 4. So then we have a vertical asymptote at x equals negative 4. So if we go back to negative 4, we're just going to draw a vertical line right there. Okay. And then to find the horizontal asymptote, I'm going to look at the degrees. So the degree on top is a first degree. The degree on bottom is also a first degree. So that means that the horizontal asymptote is going to be a ratio of the leading coefficients because p equals q. So that's just going to be 1 over 1, which equals 1. So we have a horizontal asymptote at y equals 1. Okay, and then the last thing here, we can't just like guess where this is going to be. We need to figure out like where this is positive and negative. So I'm going to look at my like important points here. So look at points where it crosses the x-axis. So we have this negative 4 and then we have the positive 4. I don't care about the horizontal one, just the vertical one. Okay, so that's why I put negative 4 and 4 on the number line. So then here, I'm going to plug in a number less than negative 4. So let's plug in negative 5. So negative 5 minus 4, that's going to give me a negative on top. I'm going to get a negative on bottom, which means a negative divided by a negative is a positive. So that's going to be positive on that part of the graph. And then between negative 4 and 4 would be like 0. 0 is the easiest, so let's just plug in 0. So that's negative 4 over 4, which is negative 1. So then in there, it's negative, it's under the x-axis. Above 4, let's say 5. So if I plug in 5, I get a positive on top, positive on bottom, so that's positive. This tells us, so this means it's above the x-axis here, above, below, and above. Okay, so if we graph this, the left side's going to look like that because it always just goes along the asymptotes. We just need to know, like, is it in the positive or the negative? And then the right side looks like that, and it just crosses over at that x-intercept there. Okay. So then our domain here is negative infinity to negative 4, and then negative 4 to infinity. Our range is negative infinity to 1, and then 1 to infinity. Domain is your x values, left to right. Range is your y values, bottom to top. Okay. This one, x cubed plus 3x squared over x squared plus 2x minus 3. So let's factor it. That's going to be x squared, x plus 3, and then x plus 3x minus 1. We'll see we have this whole here now. So we have that whole at x plus 3. So we have x plus 3 equals 0, which means x equals negative 3. And then we're going to plug that into the simplified version of this. So f of, that should have said negative 3, is negative 3 squared over negative 3 minus 1, which is 9 over negative 4, which is negative 9 fourths. So we have a whole at -3, -9/4. And I'm going to graph that. So -3, -9/4. -9/4 is like -2.25. So that's about right there. And then we have to find, that's just an x-intercept. I was like way struggling doing that. That's an x. This is an x. X. Okay. X-intercept, we set the top equal to 0. So x squared equals 0, which means x equals 0. So our x-intercept is 0, 0. So I'm going to draw a point at 0, 0. Vertical asymptote, set the denominator equal to 0. So x minus 1 equals 0. So that means x equals 1. So there's our vertical asymptote right there at x equals 1. Now, horizontal asymptote, well, the degree on top is a second degree. The degree on bottom is a first degree. So that means P is greater than Q, which means there isn't a horizontal asymptote, but there is a slant asymptote. So we need to find the slant asymptote. So I'm going to divide this. We have x squared divided by x minus 1. I'm just going to put plus 0x plus 0 to get some fillers. So x squared divided by x is x. Multiply, so x times x is x squared. X times -1 is -x. Switch the signs. Those cancel. So 0x plus x is just x plus 0. And then x divided by x is 1. And then continue to multiply. Cancel, blah, 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 but we don't care about that. Okay? I don't even know who that is. Yeah, I'm not sure. So that means our slant asymptote is at y equals x plus 1. And remember, this is like the mx plus b. So that means our slope is 1, or 1 over 1, and our b is 1. So that means we cross the y-axis at 1. So then that's why I got this over here. So like there's my y-intercept, and then I go up 1 over 1, up 1 over 1, up 1 over 1, until we get that line. Okay. Then we have to do our number line. So the only times that I care about, we only look at like your x-intercept and your vertical asymptotes. So we have 0 and 1. So let's plug in like -1. So if you plug in -1, you get a positive on top and negative on bottom. So that ends up being negative. If you go between 0 and 1, let's do like 1/2. Well, we get a positive on top, a negative on bottom. So again, that's negative also. So that means it's just going to go up and touch that line and then go back down. And then above 1, let's say 2. So you get a positive on top, positive on bottom. So that must be positive. Okay, and then you just follow right along your line. So that goes like that, and then the top part's like that. Okay. Domain here is -infinity to -3, -3 to 1, and then 1 to infinity. Our range here is a little bit different. So see how we have this point right here? There's like this big old gap right there. We need to figure out what that minimum point right there is. Okay, and the way I did this is I just used my calculator, plugged the graph into your calculator, use like the second trace minimum to find that point, and you get 2, 4. So then the range here is going to be -infinity to -9/4 because of the whole, except for that's wrong. I'm sorry. All these mistakes being made. Learn from all my mistakes. Even though, see, there's a hole right here, but there's not a hole there. So that means the -9/4 isn't actually affecting our range here. So this is going to be -infinity to 0. And then 4, and then put like the little u, 4 to infinity. Okay, my bad. Alrighty, next. X minus 6 over x squared minus 6x. So then factor it, those x minus 6's cancel, so that means we have a whole at x minus 6 equals 0, so x equals 6. Then if we plug that in, f of 6 equals 1/6, so that means that our whole is at 6, 1/6. So that's going to be like right there. Okay. X-intercept, 1 equals 0. 1 is never going to equal 0, so that's never true. There is no x-intercept. Vertical asymptote is x equals 0, so it would just be on the y-axis there. Horizontal asymptote, P, or the top is a 0 with degree. I don't know if that's like correct mathology, terminology, whatever. But there's no degree on top, and it's a first degree on bottom, so the degree on top is less than the degree on bottom, which means the horizontal asymptote is at y equals 0. Which makes sense why we don't have an x-intercept then. Okay, so then if we graph this, we only have one critical point at 0. So if I plug in a negative, well, you're going to get a negative. If you plug in a positive, you're going to get a positive. And I always plug it into my simplified part of the equation. So that means the left side of this looks like that, because it's in the negative, it's below the x-axis, and the right side looks like that. Okay? Domain here is negative infinity to 0, 0 to 6, and then 6 to infinity. The range here is negative infinity to 0, 0 to 1/6, and then 1/6 to infinity. And this time we have to include that because like it doesn't go back down right there. Okay. This one, so x squared plus 3x minus 28 over x squared plus 12x plus 35. So that top is x plus 7, x minus 4 over x plus 5, x minus 7, or x plus 7. So we have a hole here at x equals 7. Plug it into that simplified version. So you have negative 7 minus 4 over negative 7 plus 5, which is negative 11 over negative 2, which is 11 over 2. So we have a hole at negative 7 and 11/2, or 5.5. You could just write 5.5. So then that hole is right there. To find our x-intercept, so x minus 4 equals 0, which means x equals 4. So then there's our x-intercept. Vertical asymptote, x plus 5 equals 0, which means x equals negative 5. So there's that. Horizontal asymptote, the degree on top's a first degree, degree on bottom's a first degree, so P equals Q, which means it's just a ratio of the leading coefficients. They're both 1, so that means our horizontal asymptote is at y equals 1. And then we need to make our little table. And I mean, you can kind of guess like what's going to happen. Like I bet it's positive, negative, positive. But let's just double check. So negative 5 and 4. So if we plug in like negative 6, we end up with a positive because there's negative on top, negative on bottom. Negative divided by negative is a positive. So that's a positive. If we plug in 0, because that's between negative 5 and 4, you get a negative. Then if we plug in like 5, we get a positive. Okay, so that means the left side looks like that and the right side looks like that. Okay, the domain here is negative infinity to negative 7 to 5, negative 5, and then negative 5 to infinity. Range is negative infinity to 1, 1 to 11/2, then 11/2 to infinity. Okay, let's do this one. So we have x squared minus 4x plus minus 5 over 2x plus 2. Factor it, you get x minus 5, x plus 1 over 2, x plus 1. Well, those x plus 1s, that's a whole at x equals 1. Plug it into there and you get negative 1 minus 5 over 2, which is negative 6 over 2, which is negative 3. So we have a whole at negative 1, negative 3. We can graph that. And then here, I noticed that, okay, there's no x value in the bottom. So let's just see if we can make this into an equation that is easy to graph. So I'm just going to divide both by 2. So that's x over 2 over minus 5 over 2, which is the same as 1/2 x minus 5/2, which looks a whole lot like line. Okay, and the y equals mx plus b. Where our m here is 1/2, our b is negative 5/2. So that means our slope is 1/2, our y-intercept is negative 5/2. So I can just graph that, go down negative 5/2, and then go up 1 over 2, up 1 over 2, and there is that line. Okay, if that ever happens and you don't have any x's left in the denominator, it is probably just a line. Okay? And from this, I can see that the x-intercept is 5, 0. And you could have gotten that by setting x minus 5 equal to 0. There's no vertical asymptote nor horizontal asymptote. Domain is negative infinity to negative 1, negative 1 to infinity. Range is negative infinity to negative 3, and negative 3 to infinity. Okay? It's just kind of funny. SpongeBob is funny. I like SpongeBob, and I'm 26 years old. I'm a math teacher, and I can admit that. A teenager can admit that they like SpongeBob. Okay, anyway, yep, that's it. So, bye.